In this video we will showcase GLASSgo in detecting homologs of the small RNA NSIR4. NSIR4 is a cyanobacterial small RNA that has been detected in synecocystis by Clan and co-workers. It is involved in regulation of glutamine synthetase, which is a key enzyme in the biological nitrogen assimilation. Candidate sRNAs are initially tested for evolutionary conservation, as this indicates its functional importance. And in their original work, the authors detected a wide conservation of NSIR4 in cyanobacteria. And this is done by testing for homologs which are conserved at the sequence and structural level. And GLASSgo is best suited for this task. By providing a single input sequence, GLASSgo automatically generates sets of conserved sRNAs. Now where can we use GLASSgo? GLASSgo can be installed on a local Galaxy instance, for which we have provided another video that deals with the installation and setup. However, we recommend using the European Galaxy server that includes tools with the focus on RNA. On there, GLASSgo is ready to use, and it provides a powerful underlying architecture that is accessible to everyone. And lastly, the GLASSgo web server can also be used, and it provides the identical user experience. We begin by uploading a single sRNA sequence. Here, this is a FASTA file that contains only the sequence of NSIR4. We wait while it's being processed, and then we inspect its content. And this 70 nucleotide long sRNA will then be the input sequence for GLASSgo. And now just type in GLASSgo in the text field at the top left and click on it to see the user interface. Just select the sRNA we just uploaded and the BLAST database. The GLASSgo search is by default based on a complete NCBI database. sRNAs show limited distribution among the phylogenetic tree, such that a targeted search in a specific taxonomic group is likely to perform better. And for this search, we're only interested in cyanobacteria. GLASSgo can be executed in either automated mode, that is sufficient for most tasks, or the parameters can be set manually. Here, the e-value controls the sensitivity of GLASSgo. A relaxed e-value of greater than 1 increases the chance to get more sequences, but also increases computation time. And the minimum allowed identity instructs GLASSgo to discard candidate sRNAs for further analysis, whose identity falls short of this value. The next option is the structure-based clustering that is used by default. It is one of the filtering steps of GLASSgo and is applied to the candidates with medium % identity. It can be done either automatically or the structure-based filtering value can be set. However, we strictly recommend using the structure-based filtering in automatic mode, and for further details we refer to the original publication of GLASSgo. Finally, the include upstream region parameter extracts the specified number of nucleotides upstream for each predicted GLASSgo hit. When all parameters are set, click on Execute to start GLASSgo. This is done, and GLASSgo now has generated a file in multi-FASTA format. There, the input sequence is the first entry and is followed by all the identified homologs. And if no homologs could be found, only the input sequence is shown. The header of the identified homologs shows the accession number of the respective genome, followed by the genomic coordinates of the proposed sRNA. And at the end of the header, the pairwise similarity value between the query and the GLASSgo hit is shown, as well as its tax ID. As shown in the original work, GLASSgo found sRNA homologs of NSIR4 in a variety of genomes, and this includes more distantly related strains, as shown in this entry from Synechococcus. With this, GLASSgo provides a list of candidate sRNAs that indicates a wide conservation of NSIR4 in cyanobacteria. Now let's use GLASSgo again with the default settings as before. But this time we include an upstream region of 100 nucleotides. Again, the result is a single file in multi-FASTA format, but this time the header of the candidate sRNAs shows the genomic coordinates of the combined upstream region and the proposed sRNA. And the exact coordinates of the upstream region are given here at genome upstream region. And as a last note, the user interface of GLASSgo within Galaxy follows that of the web server, such that it can be used interchangeably.